Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. This video is the end of the video series, How to Apply Exponent Properties. And we are now at a self-quiz. So get a piece of paper ready, and let's kind of review very quickly the 4 rules that we talked about with exponents. All right, the following are the rules that you'll have to know for the exponents in taking this self-quiz. I have 8 questions for you to try, and before we get to those, let's just do a quick review. Let's say that we have this term, 2x squared y times xy to the third. Now remember that whenever you have a variable without an exponent, it really is to the first power, so just remember that. And the idea is, the first rule is you add the exponents. If we're multiplying like bases, so 2 times 1, that's really a 1 coefficient there, so 2 is my answer. And then I have x squared times x to the first, which is going to be x to the third. Remember, we add those exponent powers together. And y to the first times y to the third would be y to the fourth. All right, so that's the first rule of exponents. When multiplying, we add the exponents. Second rule is power of a power. All right, now everything inside the parentheses is being raised to the second power. So don't forget that really includes the 3. So you're going to do 3 squared, which we know is 9. And then we're going to square the x to the first. So it's x to the 1 times 2, or x squared. Okay? And y to the third is being squared, so that's y to the 6th. All right? Power of a power, you multiply the exponents. The next one is indication of division rule with exponents. Well, first of all, 8 divided by 2 we know is 4, so we can just simplify it that way. And x to the third divided by x to the first is x to the 3 minus 1. All right, now this part, of course, you can do in your head pretty simply, but it's really 4x squared. So if you're dividing like bases, you are going to subtract the exponents. And finally, this is one having to do with negative exponents. So y to the negative 2 power in the numerator is actually going to become y squared in the denominator. Okay, y to the negative 3 that happens to be in the denominator already is actually going to be bumped up. So we're going to have a y to the 3rd power on the top. The 3x to the 4th, nothing is happening with that, so it actually just stays right where it is. All right, so the idea again with negative exponents is if it's in the numerator, you rewrite it with a positive exponent, putting it in the denominator. If it's already in the denominator, a negative exponent becomes positive and we move it up. So an expression like this is not considered simplified unless all the negative exponents are converted to positive exponents. Now I know I could do some simplification further, and that would be 3x to the 4th, and notice how these y's would cancel out, leaving an extra y on the top. So actually my final answer there would be 3x to the 4th y. And the final rule is the 0 exponent rule. Anytime you have anything to the 0 power, it's 1. So I actually have 8 times 1 times y squared times 1. Okay? Anything to the 0 power is 1. So I'm going to have actually 8y squared. All right, so look for that example in some of the later problems on this self-quiz. Here we go. You try these first 4 problems, and then I'll show you the answers and we'll work through it. All right, for number 1, we have negative 2 times 3 times 3, which will give us negative 18. And this x to the 3rd times this x to the 1st is going to give me my x to the 4th part. And y squared times y to the 4th times y to the 2nd. Remember, we add those exponents together, y to the 8th. Final answer. All right, number 2, I hope you gave this a shot. It's 2 times 1, actually, but you still have a 2 coefficient. And then we have n to the first times n to the fourth. That gives me my n to the fifth. M squared times m to the third is m to the fifth. Add those exponents together. Number 3, here we have a power of a power. So let's just do a little problem off to the side. That's -4 to, or -2 to the fourth power. That's -2 times -2 times -2 times -2. Turns out to be a positive 16. This x squared raised to the fourth power. Remember, power of a power, you multiply the exponents. So that's x to the 8th. All right. Now, we're going to multiply that by x to the fourth y squared, which is why I get this for my final answer. Number 4, vu to the fourth raised to the fourth power. Well, that's going to give us v to the fourth power, because it's the 1 power times the 4, and u to the 16th power. Multiply those exponents together. All right, here we have 2 to the fourth, which is 16, v to the fourth, and u to the 12th. All right, now since we're multiplying these two terms together, we are going to add those exponents, and that's why we get this as my final answer. All right, let's do 4 more. Number 5, first of all, let's go ahead and combine this denominator here. And so we would get the 2u to the third, v to the third on the top. And this would give us 2u to the 6th. Let me write that down. And the v to the third is going to stay v to the third. And all of that is being raised to the third power, as it's shown here. Point, we have a couple of choices. We could simplify what's inside the parentheses and then do the power of a power, or we could do the power of the power and we'll be working with some pretty big numbers there and then try to simplify that. I'm going to go ahead and simplify first, which means that these 2's here would cancel out, and if I have u to the 6th and u to the 3rd here on the top, that's going to cancel out all the u's on the top and give me u to the 3rd in the denominator. Hopefully that's clear to you there. And this v to the 3rd and this v to the 3rd cancel each other out. So really, what I now have is everything's gone on the top, so that's going to be a 1. And I have u to the 3rd as a denominator. All of that's raised to the 3rd power. And you can see why the answer would be this. Okay, 1 to the 3rd power on the top, and u to the 3rd power raised to the 3rd power on the bottom, which is u to the 9th. All right, number 6 looks quite messy, but let's go ahead and see if we can do some canceling first. Again, we're going to compare any factor on the top with the factor on the bottom, and I noticed that these 2's can cancel each other out, leaving me with just a 2 over there on the top. Let's go ahead and write that down. And then I have an x to the first and an x squared and an x to the 4th. So think about it. There's x cubed on the top and an x to the 4th on the bottom. So all these x's on the top will disappear, leave me with just a single x in the denominator. So let's go ahead and put that x in the denominator there. And then I have y squared times another y, that's y to the 3rd, with a y squared there. Actually, these y squareds can cancel each other out, leave me with a y term next to the 2 on the top. Now all of that, if I did this correctly, all of that is raised to the 4th power. Okay, now let's keep going there. Notice how that this 2 is raised to the 4th power. That gives me the 16. The y to the 1st power raised to the 4th power is y to the 4th, and on the bottom, x to the 4th. All right, pretty messy to start with, but it reduces out fairly nicely. Number 7, this m to the 0 is going to be 1, so we can pretty much ignore that. And this n to the 4th is going to drop down to the denominator of a fraction, and everything else is going to be kept on the top. So we're still going to have the 4m squared n squared, and we have the n to the 4th in the denominator. And notice how if we do some canceling here, that will give me an n squared in the denominator, and that's my final answer there. All right. Number 8. I have the 2 factor, which is still going to be in the top. This b to the 3rd is going to stay on the top. And this a to the negative 2, a to the negative 1, combined, multiplied there, gives me a to the negative 3. And because it's a negative exponent, it drops to the denominator. So there we go. Dealing with some negative exponents and some 0 exponents, and that's a simplified expression. All right, thanks again for watching this video series. I hope that it kind of built up to some more challenging exercises for you, and you hopefully are pretty good now, pretty confident about all those rules dealing with exponents. Thanks for watching. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard,